from Missouri State University's Baker Observatory. Please welcome Mike Reed.
Thank you very much for being here, and thanks to 417Biz for inviting me to be able to have the opportunity to talk to you a little bit about this wonderful facility we have here. I guess we were already there. This is near Marshfield, Missouri, and this is run by Missouri State University, and this was all developed locally. So I'm going to tell you a little bit about our facility and then some of the wonderful work that we've been able to do by using this. So this began back in the 1970s. Then SMS, as probably most of you remember us by anyway. That's what I remember us by. We started to look for land to build an observatory to use, especially to give our students opportunities. So the students can go out there, they can see the skies and see what's going on. And so back in 1971, George Wolfe began planning this. If you remember him, he had a very popular telecourse that a lot of people saw on late night TV when they couldn't sleep. And so our land was donated by Bill and Aretha Stone Baker back in 1977. And it was an interesting process of how we ended up with this land. So it's out by Marshfield. This is the Google Eye view of it. And initially, it started off with just this little patch here. This is where the observatory building itself is. And the reason that we ended up out there by Marshfield is because Mr. Baker was in fact a historian, and he lived in Marshfield, and he knew that Marshfield was the birthplace of William Hubble. And so he sort of insisted that we build our observatory out there because it's close to where Hubble was born. And he agreed that if we did that, he would actually buy up adjacent pieces of land so that development couldn't go in there and ruin our night skies. So while he originally gave us a fairly small piece of land, by this point we actually own all of this around here and up over here. That all belongs to Missouri State University. He bought that up and he donated it so that there's no development that could encroach on our dark skies. So things didn't really proceed overly quick. It took a little while to get things going, not until the 80s. In the 80s, we finally got a building out here. And the domes themselves, the building was open until 1981. And then we got initially we had a 14-inch telescope in this dome, which is still there. And then in 1984, we ended up getting a 16-inch telescope over there that was actually donated by our national facility. It originally was a telescope in Kitt Peak, Arizona. Then it went down to our observatory in Chile. And then it ended up coming back up here. And so it took about 25 years to get this developed, and we had a lot of nice local contributors, without which this never would have happened. This was really, Dr. Wolfe did this on a shoestring. He did an amazing work. And so we have all these people to thank. Roast Ready, I think, poured our building. It's not a cement block building. It's actually a poured cement building, which is a bit different. And Meeks contributed a lot of lumber, and Frank Lawrence, I believe, was an electrician who helped. He did all the wiring for free, and Dr. Stephen Bodansky also gave a nice contribution to make this observatory work. So to zoom in a little bit on what our current facility looks like, again from our Google Eye view, this is that building. We have this cement pad out here where we take our classes out there, and they set up telescopes, and they can learn how the astronomy works in the night sky. We also have this guy down here towards the bottom is actually a robotic telescope. So that was developed by Missouri State University with some computer science students, and that's made to actually run autonomously so I can sleep nights. So we're still developing, and a couple years ago we did an upgrade. We finally got rid of that 1950s telescope, 16-inch telescope. It was a great telescope, but we upgraded to a 20-inch brand new modern telescope. And this year we're actually in the process of also roboticizing and automating this facility so that Students can use it remotely, and again, I can sleep nights. So that's a bit of history of how we ended up getting to this place. But we actually do some really interesting things here that contribute farther than you might think for a smallish telescope in southwest Missouri. These are some former students. Whoops. These are some former students that were working on instrument. We get our students out there, and they get to contribute. And so we actually do a lot of research there. And I guess now I could really advertise that this is the only astronomy research facility in the state. This is the only research observatory. There are other observatories, but this is the only one from which we actually publish data. And so now hopefully I can entertain you a little bit in that this is a beautiful picture of some stars. This wasn't taken at our observatory. This is a Hubble picture, so it's related to our observatory at least. And a decade ago, when we looked up at these stars, beautiful as they are, we knew that about 5% of those stars had planets, had solar systems around them. In the last 10 years, this is a very new science. We know that when you look at that picture, or when you look up in the night sky, virtually every star you see has planets, and typically more than one. At least 90% of those stars have planets. 9 out of every 10. It's an outstanding number. It's amazing. We never thought it would have been so high. And so one of the main contributors of how we see those is by using this method called transits. That is, you have a star, but of course, from a distance, stars are all dots. So we can't really see the surface of a star, even with the best telescopes, even with the Hubble. And so what happens is when this planet, which goes in front of the star, so planets like the Earth doesn't really emit any light, they only reflect light from their stars. And so how we can detect them best is if they go in front of their star, then they block a small amount of that light. If some aliens were looking at us and the Earth went in front of our sun from their perspective, we would block 1/100% of the sunlight. So it's a very small amount. Jupiter would block about 1% because it's much bigger than us. And so we actually observe these sorts of things from Baker Observatory. Sorry, move back up for a second. So if you have one planet that transits, you see something like this. But if you have a solar system, again like ours, you may not see all those planets actually transit. Perhaps if you were looking at our solar system from a long ways away, perhaps Mercury and Venus, which are the closest, the most likely to transit, maybe they would transit. But if we're at a little bit of an angle, all of the other 6 planets, maybe they wouldn't transit. So how would you know that they're there? And that's some of the work actually that we're doing at Baker Observatory. And how we do that is even if all of these planets out here don't transit, they actually affect the timing of the transit for the planets that do happen. Because the whole solar system, and every solar system, is kind of like on a balance. And those planets out there move the star around by some tiny amounts. And that can change when those transits occur, and it could change them by a few minutes or even up to several hours, depending on how massive they are. Jupiter actually moves our sun around a fair bit. Couple of minutes, I think, if we were doing the timing for our solar system. So this is an example of what we have observed at Baker Observatory, and it's not quite as beautiful as the graphic. The red points are the actual individual data points, and then we average them out to get those black points. But again, you can see this is before the transit began, if you can see that pointer. And then the dip occurs and the transit begins. This one lasted for about 3 hours, and then it ended, and we stopped observing. This is just an example of another one. Maybe it's a little prettier than the previous one. And so these are stars that we can observe them doing the transits. And in fact, these two transits themselves when we compared our observations to when the predicted transit was supposed to occur, they were both off by about 15 minutes. And so that means it's fairly likely that these solar systems have other planets that we don't know about transiting. And so a lot of our work is actually to discover new planets by using this method. So we'll have to observe these more because we have to actually get a complete orbital cycle of the unseen planet, and then we can determine the planet that isn't there. So besides just doing that work, we're also helping NASA out. There are a couple of planet-finding space telescopes. The one on the bottom right is the Kepler Space Telescope. That mission is done. And so for the planets that it found, we do continual follow-up to make their orbits more precise or look for unseen planets. And the one on the top left is called TESS. That's operating right now. And from our observatory, we're getting some simultaneous observations. And then we also will do follow-up for those planets as well. We're part of that follow-up program. So we're contributing to these missions to help us find and characterize these other solar systems, especially for planets that aren't seen. But our work has already had somewhat of an impact in that our sun is very long-lived, but it's not forever. It is using fuel, and that means eventually it will have a little hiccup itself. And when that happens, our sun will actually expand. So this little dot in the center is the current size of our sun. And when our sun, in 5 billion years, so you don't have to worry about the insurance on your house yet. In 5 billion years, our sun will expand, and it will consume Mercury. It'll be vaporized. It will consume Venus, and it will get out actually about past the size of Earth's orbit. And so a question that had been, question that astronomers were trying to answer was, what will happen to the Earth? Will the Earth also be in the atmosphere of the sun and therefore be vaporized, or will it survive this phase? Well, we actually observed a planet around a star that had already passed that phase. And that planet actually survived. So now we know that when our sun in 5 billion years expands, the Earth will actually migrate outwards and will end up at about Mars's orbit. So you can set your calendars, in about 6 billion years you could come back. Unfortunately, there probably won't be any atmosphere left or plants or water, but bring it with you and it'll be okay. So we've actually had some pretty interesting results from our observatory that we contributed to, which makes us very happy. But also, so that's two things. It was nice to get our observatory out there. We use it for students. We use it for research to try and find real things. But we also like to share that with the public and engage the public in outreach events at our observatory. And just as a show of hands, I can see some. Have any of you been to the observatory for our open houses? Yeah, a few. Thanks. We love to have you guys out there. So these are some pictures from some of our events, and you can see that we have quite a few people out there. Every year, we have literally hundreds, actually probably a couple of thousand people out over the course of a year for our public events. These open houses begin roughly at sunset, and they run a couple of hours. And it's a chance for you guys to come and share the experience with us. We put eyepieces on all of our telescopes. We usually set up about 6 or 8 telescopes. And we look at different things in the skies, not just stars, but sometimes galaxies, nebulae, things like that, things that are interesting. And you can quiz us about our astronomical knowledge to see if it truly is astronomical, I guess. So we have some upcoming dates. Our first date will be on Leap Day. So that's an extra day. You don't have to work. That's a Saturday. These are all Saturdays, so you don't have to work. And I know our first one is going to begin at 6:30, which I think is about a half hour after sunset. We'll run 2 or 3 hours. And so hopefully you guys will all get a chance and come out. And our next one will be in March, towards the end of March, and then one in early May. We don't run any in the summertime because we're a 9-month university for the most part, and it gets dark very, very late, so that's past my bedtime. So we try not to do that, but anyway, thanks very much for letting me talk and share some of our observatory with you, and I hope that you will all come out and see us at one of our events this spring, or if not, we'll have 3 next fall as well. And if you have any questions or any interest in a few $1,000,000 to spare and you want to throw your name on a new building, we'd be happy to put one up. And I'll be around during the break, but I'm looking forward to the next 2 talks as well. So thanks very much for hearing me.